Ruby, what can we gather from what has already and actually gone forth from and via this great wheel of all? It operates horrendously slow except when it begins a universe with a lot of waste and extravagance, as if it wasn't able to do anything any other way, it thus matching just what we'd expect of a purely physical nature given its tiny fundamental components, life not seeming to be of any immediate concern. A big bang happened at some arbitrary time and place, with a near forever having passed, and apparently a past eternal already having done so, as if it's some rare event coming out of eternity's waiting room in which a lot of meaningless time can pass before the right conditions obtain. We surfers of light are of only 4% of the universe's stuff. Please comment as I go on. I add, a quark gluon plasma comes forth later, which had to cool off during 380,000 years of opaqueness, which we cannot penetrate yet, but hope to do via its gravity waves, after which time there came light, with photons, protons, and the first few simple atomic elements unto stars making the rest, then molecules which luckily are neither inclined to form or to stay together after, RNA, DNA, cells, organisms, brains, consciousness, this life seeming as a kind of afterthought. Sorry, I'm getting too far ahead. Ruby looks up as if through the ceiling and up to the stars, remarking, I've come such a long way to be here with you. But our possibility was there in the beginning, although spread all over. The Planck era at 1e43 seconds was the first hint of us, as a cyclical compactification or a vacuum fluctuation eruption in an indefinite realm that's as close to nothing as can be, but it can't be a nothing as such, since that would be a definite, whereas the vacuum as the basic quantum something must be fuzzy, uncaused, and undirected, matching that which we often note in the quantum realm. Apparently motion can't cease, for energy cannot be destroyed. I'll knock stillness off of the list of what can be as being a kind of a cousin of nothing, which we've already banished along with ultimate beginnings and ends plus infinity, because it can't be capped and so it cannot be had all at once or ever, since one can always add to it. It never completes, and that is more toward its meaning, not any meaning that it is a number or an amount. I'll add random as probably requiring a fundamental level or the quantum level, and as dubious otherwise as it's mostly evened out at the macroscopic level. Life's spirit to the causeless was near blind. Quoth I, if the beginning you could find, the aleph of word, phrase, and universe, thou needs not the alphabet, all's been mined. Night is falling and dinner is on the cusp. We take a break from our game of pool and obtain another drink, Houdini's vodka gimlet from Martin's bar. Ruby Yacht readies to continues her cosmic description, naming it the history of all history of our universe, from the first instant unto the last. Martin braces himself for the shower of cosmology that is about to spew forth to bear the rafters of the universe's beginning, middle, and end, and so he raises 3 glasses in bodily toast to all and especially to Ruby. My heart's blood gleams like a melted ruby, the wealth of mine, the gem that flows in me. My goblet enshrines my wounded heart's tears. Wine is my soul and the cup my body. Bring thy ruby mind in a crystal thrust, the drink that raises one up from the dust, for who knows what breezes blow into gales. This world is but a passing whirlwind's gust. Rubies from the vine's mines are melted up as the moon veil dissolved in the sun's sup. In pearled crystal goblets of the flow, oh, sparkle with life's essence sweet thy cup. The great wheel of our universe proceeds very quickly at first. At 1e36 seconds, in a gut transition in a hell of a short time, the strong force separates from the electro-weak force, the strong force eventually providing for stability and the weak force for changeability, another great balance. Inflation begins maybe as a slow rolling scalar field generates negative pressure, causing an exponential expansion of space-time. The doubling is of a vacuum energy density of 1e73 tons cm cubed. Quantum fluctuations lock in nearly scale invariant 1e5 variation in energy density. Here the enigma of the ever-immortal is undone and unloosed through its portal. Or at least inflation is proposed, for nothing else makes sense yet. The galaxies would seem to be the quantum fluctuations writ large across the night sky. She continues, we alternating. At 1e34 seconds, inflation quickly ends, the decay of the scalar inflaton field causing reheating. Is this the let there be light moment? No, photons don't exist yet, but other massless vector quanta like left and right weak and BL particles may exist. Things are not well known about this era. You and I are still but a twinkling in the cosmic eye. What is here now was there in the beginning. At 1e34 to 1e8 seconds in the quark era, there is the quark-gluon plasma, and then quarks and perhaps superparticles dominate matter content. At 1e17 to 1e15 seconds, SUSY breaking occurs when proposed superpartners acquire mass, with the LSP expected to have a mass of about 10 TeV. In induced gravity models, this is where mass energy first generates the induced gravity field. Gravity is born, and we are grounded. At 1e10 seconds, there comes the electroweak transition when the electroweak force under the action of the Higgs mechanism breaks symmetry. The photon is born. Standard model particles acquire mass. Yeah! The photons guide us as illumination beside us, while the mind whirls round and round as the ear draws forth the sound, as the eye sees the light and of the dark the fright. Fear not the proof, it's the beauty of the truth. At 1e5 seconds, quark confinement comes about when the QCD vacuum becomes superconducting to color magnetic current. Quarks and gluons become confined. The quarks can never exist independently again. At 1e5 to 1e4 seconds in the hadron era, protons, neutrons, and pions, etc., form. Now our future atoms are on the horizon. What a long road our parts have traveled. At 1e4 seconds, hadron annihilation occurs during a brief period of proton-antiproton and neutron-antineutron annihilation. A slight favoring of matter over antimatter, possibly locked in by CP violation at reheating, allows some very few excess protons and neutrons to survive. With 10 billion photons for every matter particle now, which tells us how many annihilations there were, as 10*9, along with how much more there initially was. It's still a humongous amount of stuff, albeit gone from 2x1076. At 1e4 to 10 seconds in the next era, leptons are the dominant energy density, such as electrons. We are up to about 1 second after the Big Bang now at neutrino decoupling, when mass energy falls low enough to free neutrinos, creating the neutrino cosmic background. We've many hints from the cosmic microwave background too. At 10 seconds, electrons and positrons annihilate, leaving a tiny fraction of electrons remaining. At this point, the total number of electrons equals the total number of protons. This is a beautiful symmetry. Protons are of positive charge, while electrons are negative. From 10 seconds to 57,000 years is the radiation era, in which photons created from the annihilation of matter and antimatter dominate the energy density of universe. Light has been let, we will shine. Of course, our shining turns out to be another very slow part later in bioevolution, taking 4 billion years. At 5 minutes, nucleosynthesis begins as fusion of protons creates helium, deuterium, and trace amounts of lithium. A few of our basics are there. Hydrogen is already present, it being so simple. From the simple, composites and complexities form, as we ever note, through and through. At 57,000 years, there is matter-radiation equality. The radiation density, photon and neutrino, and matter density, dark and atomic, are equal. This is because radiation density falls more quickly due to the stretching of the relativistic particles' wavelengths. Dark matter clumps into structures. Atomic matter begins oscillation due to the battle between gravity and photon pressure, generating acoustic oscillations. The first sounds of the new universe come forth as the word gravity ever pulls back toward the past, but the electromagnetic waves ever pull ahead toward the future. At 380,000 years, there is recombination. When the temperature falls low enough to allow atoms to form, photons decouple. The true CMB is born, locking in its structure, the story of the earliest times in the universe. The radiation by now has been shifted into the microwave portion of the EM spectrum. For 5 to 200 million years, there is a dark age as the photons fall into the infrared energy range. The universe goes dark. The atomic gas continues to fall toward the dark matter clumps, which grow more pronounced. Near to 100 million years, the densest clumps halt their expansion and begin collapsing. By 200 million years, the first mini-halos form, and within these, the atomic cloud cools and collapses to make the very first stars, whose light brings to an end the dark era. We are totally the hopes of further stars yet to become. By the way, I forgot that inflation could have been so fast that some virtual particles couldn't recombine, thus becoming real. It's auspicious and of good fortune in the meadows of heaven. At 200 million years, there are the first stars, which are very massive and short-lived, but emit some lower atomic elements since this doesn't require extra energy. They die in violent supernova explosions, filling the cosmos with the higher atomic elements that needed energy to be added, building dust for new stars and the planets of solar systems, and the elements for life. The later generation stars are much more metal-rich, this needed for solar system life to form. At 200 to 800 million years, there is the epoch of ionization, in which the radiation from the stars and possibly the first quasars ionizes much of the remaining neutral hydrogen and helium. A thin mist returns and partly obscures the CMB, but future low-frequency radio telescopes may be able to see the epoch of ionization. We're getting through the first billion years. Scene script. At 1 to 2 billion years, there become infant galaxies as star groups merge. There are frequent collisions of galaxies, high star birth rates, and high supernova rates. Heavy element production changes the pattern of star formation, making them lower mass, less luminous, and longer lived, like the second-generation stars of today. The stage is set for the emergence of life. The cosmos will soon have eyes to see and minds to think like ours. Your soon takes another 10 billion years. At 2 to 3 billion years, there is a star birth and quasar peak. In the dense environment of frequent galaxy collisions, the star birth rate reaches its maximum, as does the forming and feeding of supermassive black holes, as horrible darkling beasts. Abandon hope, all ye who enter there. 4 to 5 billion years gone, and just as much to go to achieve the very early life of bacteria, who, by the way, took 2 billion years to make Earth's atmosphere by exuding oxygen as a waste product, as it was poisonous to them. Slow indeed. At 6 billion years, there are the first very rich galaxy clusters, since enough time has elapsed for the densest regions to stop expanding and form these clusters. At 7 billion years, there is decelerated acceleration. The effects of dark energy kick in. The universe once again begins to accelerate its expansion rate, but gentler. Gravity has lost the battle. At 8 billion years, the first modern spiral galaxies form, although some elliptical galaxies form in the first billion years. But classic spiral galaxies aren't seen until at about 5 billion years. Let's skip over the next 3 billion years. That should be enough time for us to have dinner. Yeah, nothing is near instant but for the Big Bang, and I'm starving.